Okay, so I'm going to mute everybody. And John, you'll need to unmute yourself so that you can be heard. So, okay, so I'll mute everybody now. And if John, you can unmute yourself now.
Yeah, okay.
Great, okay, I think we're ready to go. Okay, so it's a great pleasure to welcome you, really, because this is there's always been a strong biological connection in ANPA, but I think I'm thinking what you're going to say here is going to make a very important connection between the physics and the biology.
Okay, so how do I advance the slides?
Oh, you just ask me and I'll do it.
Oh, I see. Got it. Okay. Yeah, so I wanted to say that I have actually tried to incorporate some of this discussions we've had over the last week in various places in this talk to try and make it more relevant than it might otherwise be. But please ask questions. I feel like the beggar at the banquet as a biologist, but with all those apologies, let's get on with it. So I'm a professor of various things at UCLA, but I'm speaking to you from sunny Philadelphia. And okay, with that, the next slide. So this is the David Foster Wallace's commencement address at Kenyon College in 2005. And so the story goes, there are these two little fish and they're swimming along, and this old fish comes up to them in the opposite direction and says, "Hi boys, how's the water?" And one little fish says to the other, "What the hell is water?" I'm going to talk about what water is. Next slide. So in the beginning, we know we have, so everything I'm going to talk about is experimentally based. My own work and that of others. We know that lipids in water were present in the primordial ocean that covered the earth. Robert Frost has told us that life is that which can mix oil and water. Of course, the poets are always a few steps ahead of us. It's just that he didn't have the data to substantiate what he was saying, but he was absolutely correct in my opinion. So when you immerse lipids in water, they form what are called micelles spontaneously. These are primitive cell-like structures with a semi-permeable membrane. And when those micelles were formed, if I use David Bohm's parlance, there was only the implicate. And then, so how do I advance this, Mark?
Oh, sorry, I'll do it.
Okay, so advance it, please.
Yeah.
Yeah. And then the explicate.
Oh, sorry. Yeah.
The explicate appeared. So biology really is dictating the differential between the explicate, which is what Bohm considered to be our subjective way of seeing reality, from the implicate, which was there all along. Next slide, please. So thank you to Mark and Peter and Andrew for inviting me to speak at this ANPA conference. Ernest Rutherford said that all science is either physics or stamp collecting. Maybe so, but absent biology, there would be no physics as a discipline. So as an old stamp collector, I hope I can convince you of the relevance of understanding biology to understand physics. Everything I'm about to talk about is based on experimental evidence, either my own or that of others, as I said earlier. I have deconvoluted long evolution as a model for tracing the exapted pre-adaptive stages from one adaptation to the next, back to the unicellular state. Next slide. We systematically err in tracing our evolution from the present backwards, which is reasoning after the fact, which we know is illogical. Up until now, that's always been all that's been available to us to try and determine who and what we are. But since the advent of cell culture in the mid-20th century, we've had the opportunity to study live cells in isolation. The following is the application of this methodology to reveal our evolution from its beginnings in the unicellular state and what it teaches us. Next slide. So there are fundamental scientific problems that have faced humanity throughout history. The world is flat. The Earth is the center of the solar system. Stress causes duodenal ulcer. Darwinian evolution as reproductive success is an epiphenomenon resulting from reasoning after the fact. As a result, so quantum mechanics does not, and the problem we're having currently is that quantum mechanics does not align with reality. There was an interesting article in the New York Times Magazine section on June 25th, profiling Angelo Bazzi, an Italian physicist, highlighting this problem, the misalignment of quantum mechanics with what we think of as reality. So my overall hypothesis is that the mismatch of quantum mechanics and our reality is due to the backward perspective we have for understanding evolution. Next slide. So I'm going to contrast Darwin, Stephen Jay Gouldian, Eldridge, and my quantal theory of evolution. The stepwise epigenetic cell-cell homeostatic give and take between cells as they reconfigure themselves to fit with ever-changing environmental conditions is quantal, not graded as Darwin had suggested in his book, The Origin of Species in 1859, or punctuated as Eldridge and Gould had hypothesized in their 1972 classic paper. Next. Niels Bohr's complementarity theory of light, the particle-wave duality, is a function of how we measure light. Next. The same idea holds true for gradualism versus punctuated equilibrium versus quantal evolution. It's how you measure the process. Next. So here's a schematic depicting what I just said. So gradualism assumes that it's adult reproductive strategy which gives rise to offspring, and the number of offspring is indicative of the evolutionary success of the organism. This is a cheap shot. It's bean counting as far as I'm concerned, and I'll explain that further. And with apologies to Darwin, I know he's a British hero, but hey, I'm an iconoclast. Punctuated equilibrium, I'm depicting it as a linear process, and that periodically we see these nodes that appear during evolution, and this is what Gould and Eldridge were referring to as punctuated equilibrium. But again, it's a measurement issue. I'm saying that evolution is a function of cellular interactions, and when they become stressed, they give rise to the evolutionary strategy in a quantal form, not as a continuum, either gradualism or punctuated equilibrium. Next slide, please. So in 2019, I published a paper entitled The Singularity of Nature, based on the foundational interrelationship between the inanimate and the animate, the atom and the cell being homologs. That is to say, they are of the same origin. The key to understanding this approach is the cellular molecular mechanism for development, based on cell-cell communication, mediated by soluble growth factors signaling to their receptors, first observed and published when I was in graduate school. Since that time, the essential elements of embryologic development have been determined, particularly for the lung. I'm a lung biologist by training and funding, which is existential for life outside of the womb. Next. Embryologic development is the only mechanism we know of for the formation of biologic structure and function. Darwinian evolution is descriptive, metaphoric, and there is no experimental evidence for it. Shocking. Furthermore, using phylogeny as the basis for evolution is reasoning after the fact. The key elements of the development of the alveoli of the lung, the site where gas exchange occurs in the lung, have been determined. Using that as the basis for reverse engineering of the lung, it is possible to move backwards in space and time developmentally and phylogenetically to the unicellular state, exploiting the concept of exaptation, a term coined by Gould and Verba in a paper in 1982. Basically, it's a pre-adaptive process, which states that each successive step in evolution reutilizes some earlier genetic trait. Based on that approach, many other key physiologic properties, the kidney, the heart, skeleton, and brain, for example, have all been traced back to the unicellular state, as I will demonstrate in a subsequent slide. Consequently, the evolution of physiology itself has now been traced forward from the unicellular state to the present state of being. Next. So I'm showing this graphically on this set of axes. I'm showing phylogeny, the history of the organism. In this case, the history of the lungs, starting with the swim bladder of fish, and going to amphibia, reptiles, and mammals, showing how the lung has evolved over time. Underpinning that is ontogeny, or developmental biology. So we see that there are these pink cells and these blue cells. See, these depict the mesoderm and the endodermal cells that line the alveoli this space in the middle. And as over time, this space or the alveoli have gotten smaller and smaller in order to accommodate more and more gas exchange. So it's a function of the ratio of the blood volume to surface area of the alveolus that dictates gas exchange. So this is all a function of cellular interactions. It was only when Einstein's classic formula for energy relating to matter, it dawned on me that that actually was the expression of the singularity of the cosmos. And that if you subtract the material from the equation, you're left with energy. And so next, so if we think it, can I have the next image? Okay, so here's a set of coordinates, and next, okay. And now as evolution has progressed, next, based upon this cellular interaction principle, each individual step in the evolution of the physiologic structures I've talked about, the lung, the kidney, the heart, et cetera, is a function of high energy phosphates. So as the cells interact, they generate these high energy phosphates, which are basically the process of evolution in its purest form. Next. And if we extrapolate backwards, we start with the origin, the singularity, the subsequent Big Bang. So this is where this energy flow originates from, hypothetically. Next slide. One way to think about this, at least for me, is to contrast the material and energetic ways of thinking about evolution. It's like the difference between Newtonian and Einsteinian concepts of gravity. So Newton's concept of gravity was the attraction of bodies in the explicate order. And by contrast, Einsteinian gravity is based upon the distortion of the fabric of space-time, which is within the implicate order. There is a gap between these two, and use the gap of the London subway as a way to express that. Okay, next slide, please. Einstein often imagined himself as pure energy instead of matter, enabling him to see the relationships between the animate and inanimate as a unity. This Gouldian experiment was the basis for his articles on Brownian movement, photoelectric effect, and special relativity in 1905. So I'm laying claim to the idea that he had a dream when he was 16 years old of traveling in tandem with a light beam. This was his way of aligning himself with the cosmos. And so he had all these insights. Next slide, please. So the anthropic principle is a systematic error that we make. It was first stated by Brandon Carter in 1974, when he stated that conditions that are observed in the universe must allow the observer to exist. The anthropic principle is diametrically opposed to the prevailing theory of cellular evolution, or endosymbiosis, which is based on the endogenization of factors like heavy metals, ions, gases, bacteria, in the environment that were an existential threat. Next slide. So there are homologies between the atom and the cell. For example, homeostasis, the Pauli exclusion principle versus the first principles of physiology, which I have stipulated, non-locality and pleiotropy, which I will explain further. Next, coherence and physiology, and wave collapse as Abraham Maslow's peak experiences. I will go through these step by step. Next slide. I'm sorry, and Heisenberg's uncertainty principle, which is consistent with the ambiguous origins of life. Next slide. So here I'm showing how homeostasis applies to both the atom and the cell. If you think of a hydrogen atom, there is this homeostatic balance between the proton and the electron, for example. And similarly, you see that the first principles of physiology, negative entropy, chemiosmosis, and homeostasis, similarly are predicated on the balance between all of these principles held together by homeostasis. Next. And I stipulate that homeostasis arose from the Big Bang in the sense that, no, next. I'm sorry, go back. Let me just explain that. In the sense that I've considered the possibility that for every action, there is an equal opposite and opposite reaction, Newton's third law of motion, and that now constitutes the homeostatic principle, because without that recoil in the cosmos, matter would not exist, only pure energy would exist. Next. The Pauli exclusion principle, when contrasted with the first principles of physiology, also shows homology. The Pauli exclusion principle, the first three variables for electron spin are determined. The fourth variable is probabilistic. Similarly, the first principles of physiology, negentropy and chemiosmosis, are determined, whereas homeostasis is probabilistic. So basically, we exist in this limbo between determinism and stochasticity. Next. Non-locality is expressed biologically as pleiotropy, the concept that the same gene can be expressed in many different tissues in the body. So the classic non-locality of the quantum theory is mimicked, if you will, biologically by the expression of the same gene in different body organs and tissues. And so you have this similar distribution of genes and as an expression of non-localization. Next. Coherence is consistent with physiology. Cell physiology is mediated by cell-cell communications, mediated by soluble growth factors and receptors. The coordination of cellular physiology is mediated by coherent calcium waves. So again, this homology between coherence and physiology, in my assessment, is one and the same process. Biology mimicking the physical quantum mechanical principle. Next. Wave collapse, I think, is like what Maslow expressed as peak experience. I took this from Wikipedia. Peak experiences are moments of extraordinary experience, such as love, understanding, happiness, or rapture, during which a person feels more whole, alive, self-sufficient, and yet a part of the world, more aware of truth, justice, harmony, and goodness. The neuroendocrine hormones produced in the mostly in the posterior pituitary of the brain, such as endorphins and oxytocin, integrate calcium flow, producing the proverbial runner's high, for example, or what happens at the time of childbirth with uterine contractions and milk letdown, respectively. The effect of such hormones is to cause wave collapse, maximizing the effect on integrated physiology. Next. Heisenberg uncertainty principle is consistent with biological ambiguity. So Heisenberg's uncertainty principle states that the position and momentum of a particle cannot be determined simultaneously. That ambiguity is mirrored by the ambiguity of life, beginning in a state of negative entropy with respect to the entropy of the surrounding environment. Next. So I've considered the possibility that the way that I've stumbled onto this concept is by overlaying phylogeny on ontogeny, because they are the same process of cell-cell communication at different timescales, if you will, from a descriptive perspective. But the possibility exists that this was actually superposition in the sense of physics, and that this is actually constituting wave collapse, which is what we think of as evolution. Next. And underpinning all of this is quantum mechanics. So this is the big picture idea. Next slide. I've depicted this, so gradualism, punctuated equilibrium, and cell-cell communication graphically. So gradualism is this unending series of evolutionary steps that Darwin envisaged. Eldridge and Gould pictured it more as islands of change in a series of events. The intermediates cannot be seen, but that's a function of how you look at, of how well you can how you can resolve these processes. It's not unlike Bohm talking in wholeness and the implicate order, stating that we think that electrons jump from one orbital to another in an atom, but in reality, he says that if we had the ability to see it, we would be able to see the atom moving from one orbital to the next. It's just a function of the technical ability to see the process. I'm contrasting the gradualism and the punctuated equilibrium with cellular communication, which is quantal. So each step in the process requires a quantal change, which can be measured and experimentally demonstrated. So there's a strong contrast here between the cellular communication principle, which is highly mechanistic, and these descriptive processes which preceded it. Next. So here I'm going to show how evolution acts, is caused by self-engineering or auto-engineering. So homeostasis is the order of the day for physiology. And when dishomeostasis occurs, we know that cells will produce radical oxygen species, which cause gene mutations and duplications. And then there is remodeling under the aegis of homeostasis. So the system is constrained by the homeostatic principle. And the net result is what we think of as evolution. So I'm contrasting this configuration with this configuration, sort of like a glomerulus in a kidney or an alveolus in the lung. But suffice it to say that evolution is auto-engineering, what Shapiro described in a view of evolution from the 21st century in bacteria, for example. Next. So what I'm suggesting here is that cell-cell communication is quantal, and it's highly homologous with physics at the quantum level, and that in turn has given rise to evolution. Next. So I'm showing here the evolution of the lung, the heart, and the kidney as prime examples of physiologic evolution. I've talked about lung evolution, the top frame. The heart, for example, evolved from a muscular blood vessel, gave rise to the fish heart, which is two-chambered, and then to the reptilian three-chambered, and then the mammalian four-chambered heart. Each of these steps is explained by specific genes that have mutated under physiologic stress, giving rise to these structural changes. I don't have time to go into the details, but trust me, it works. Similarly, the kidney has evolved from the fish kidney, in which there is this primitive glomus, which filters out electrolytes and fluids. And then there's exchange of these electrolytes and fluids with the vasculature that surrounds the descending duct of the kidney. That glomus has evolved into the glomerulus of the mammalian kidney through cellular interactions that have basically caused the evolution of a highly vascularized structure. And again, there are specific cell-cell interactions mediated by specific growth factors, which we know have caused these changes because, for example, if you delete key genes in this process, the system will revert backwards to its origins, literally. Next slide. So I'm going to talk about a thermodynamic narrative. Next slide. So again, we have, and I know Peter Rollins doesn't like the idea of hanging your hat on the Big Bang, but works for me. And I think there could be smaller bangs as opposed to a Big Bang. But at any rate, there was an impetus for evolution. The Big Bang is thought to have occurred about 13.7 billion years ago, starting with a singularity, which generated a vector from a nil point. And that physical phenomenon is what we have adopted in terms of evolution in order to remain consistent with this process, as I will explain. Next. So we know that there were meteorites that contained water and polycyclic hydrocarbons, fat, lipids, produced by pulsars that struck the Earth about 4 billion years ago, generating the ocean that covered the planet. Next. So here I'm depicting these polycyclic hydrocarbons, these lipids, aligning at the atmosphere-water interface. They do this spontaneously because they are amphiphiles. They have a negatively and a positively charged polar end, and that's what causes them to align perpendicularly like this. But that also offers the opportunity for electromagnetic forces to influence these lipids at the surface, such as photons, for example. Daniel Fells has shown that photons do in fact affect cells directly, or the electromagnetic pulsing of the force coming from pulsars for that matter. And this may in fact have been the impetus for the spontaneous formation of micelles, these lipid structures with a semi-permeable membrane surrounding them. And within that membrane, you can generate negentropy and chemiosmosis. Chemiosmosis is the simplest form of bioenergetics caused by the same thing that happens in your car battery. You have these lipid membranes within the cell, and then they align the electrolytes negatively and positively charged on either side, and that causes electron flow, which supports the negative entropic state. And this is all controlled by homeostasis. So I've highlighted in red here a comment that we discussed the other day about, in the last Zoom about the entropy of lipids and the entropy of water potentially having given rise to negentropy, because Schrodinger in his 1944 book, What is Life, merely said that life feeds on the energy from the environment, which, yeah, I mean, it sort of works, but it's not very elegant. I think that the idea that negative entropy may have been given rise to by the entropic state of the lipids in the water is a more interesting prospect. And that in turn, as Mark had suggested, had mentioned, sometimes negative entropy occurs. And I'm wondering out loud whether that's what actually occurred in this case, but that can be discussed. Next slide. In terms of the origin of memory, it is my opinion that these micelles, when they're sitting near the surface, they are warmed by the sun and they deform, because that's what lipids do, they liquefy. And at night, when it's cold, they reform. And in the process of deforming and reforming, they trap calcium ions within them. And they iteratively increase the amount of calcium in those micelles. So calcium is toxic to lipids, it causes them to denature. So there must have been a subset of these micelles which ultimately evolved calcium channels, which are the basis for our physiology. And so I'm showing that here. And again, I have no direct evidence for that, but there's a lot of indirect evidence that in fact is the case. Next slide. Endosymbiogenesis was the critical process by which simple unicellular organisms became complex physiologic organisms through the endogenization of factors within the environment which posed a threat. And the classic example is iron, which is a potent oxidizing agent. It's the core to our heme protein that facilitates the carrying of oxygen by red blood cells throughout the organism. Just as an aside, Max Perutz won the Nobel for the crystallization of the heme protein back in the 40s, and Max was a cousin of mine. So my scientific bent may have been genetic. Who knows? Next slide. So here I'm showing how cell-cell communication gives rise to the offspring, starting with a zygote, a fertilized egg, generating an energy flow. So when the egg and the sperm meet during fertilization, they give off a huge calcium burst, a burst of energy. And then step by step, we have the flow of energy being caused by these growth factor signaling mechanisms, specifically cyclic adenosine phosphate, cyclic ANP, and inositol phosphates. There are 4 of them, all of which are high energy phosphates. And when you permute and combine those processes, I'm suggesting it's an exponential process. The net result is the offspring. Next. So I'm not going to go through the details of embryogenesis, but only to say that it's a very complicated process, but in fact, it can be resolved through these cellular communications, starting with the zygote and going all the way to the embryo and birth and beyond. And each of these steps represents an energetic exchange. Next. An important concept that has emerged over the last decade or so is the reviving of the idea of niche construction, the idea that organisms actually fashion their own environment to some degree. So beaver build dams, humans build towns and cities and states and super states, and ultimately achieve Gaia, if you will, Lovelock's concept of Mother Earth. The way in which I've conceived of that is that when we have factors in the environment that are internalized, endogenized by the cell, that actually forms a continuum from what's occurring within the cell, Claude Bernard's milieu intérieur, and the outside environment. And if you iterate that process over and over again, that is ecology, basically. It's the intimate relationship between the organism and its environment. It's also Bohm's enfolding and unfolding, interestingly. So I'm suggesting that ecology and physiology are basically one and the same process, seen at different scales, if you will, or levels. Next slide. Interestingly, Simon Conway Morris, the convergenist, has said that first there were bacteria, now there is New York, which I've depicted here. And he's absolutely right. The problem is, how do you get from here to there? That's the question I'm trying to answer. Next slide. So there's a continuum of physiology, from physiology to cosmology, which I think is what we think of as consciousness. So I just described this relationship between the inside of the cell and the environment as an iterative process, following, obeying the laws of nature. And when you raise that to an exponent, ultimately it constitutes physiology, and the aggregate of our physiology is what I think of as consciousness. The brain is a highly concentrated state, a state of neurons coalescing, but there's also the peripheral nervous system. And I think that, as I will explain, consciousness is really not what we think it is. It's the connection to the consciousness of the cosmos, both of which, because both our consciousness and the cosmic consciousness that Buck described in his book in 1975 comply with the laws of nature. Next slide. So here I'm showing, experiments that I've done in my laboratory, for example, in which I've looked at parathyroid hormone-related protein messenger RNA. So PTHRP is essential for the formation of alveoli in the lung and many other physiological properties. If you put a lung or bone cell into into near zero microgravity experimentally, the PTHRP gene will shut down. It will not produce mRNA. Similarly, yeast will do the same thing. They cannot polarize and they cannot reproduce. They're basically zombies. So this is an expression of how biology is contingent and dependent upon gravity. Gravity has determined the biologic constructs. And as I explained earlier, the impinging of electromagnetic forces and photons on amphifiles may very well be the origins of these relationships and the rest of the process as I had described it. Next slide. So Hameroff and Penrose, Roger Penrose, developed the OR theory of consciousness, which is based upon microtubules in neurons acting to cause a networking of those neurons within the brain. Ironically, microtubules are present in all cells. So they've basically focused on the brain, but in reality, physiology is all about microtubules. So that's a problem there. All neurons, central and peripheral, have microtubules. Physiologic evolution is based on endosymbiosis, as I've described. Cell-cell communication provides a holistic network for consciousness. Endogenization of factors in the environment aligns our internal environment with the external environment, providing a common basis for consciousness as we think of it, and cosmic consciousness. The skin was the pre-adaptive origin of the central nervous system. And so it was a problem in evolutionary biology for a long time because nobody could figure out how we got from invertebrates to vertebrates until Nick Holland at UC San Diego realized that the skin actually is the conduit or the homologue of the central nervous system. And that resolved that problem, for example. Next slide. So here we have the vertical integration of physiology, starting with the amphifiles here at the bottom. Next. That gave rise to the first principles of physiology. Next. And now you have physiologic stress. For example, the classic example is the water-land transition, which occurred about 500 million years ago. Next. And that stress is mediated by adrenaline, which I'm showing here an inset. So there was, for example, as animals adapted to land, their lungs went through this stepwise evolution of alveoli. But as you can imagine, from time to time, there was insufficiency of oxygenation because the system just hadn't achieved a level of compatibility with the environment. Hypoxia is the most potent physiologic stressor we know of, at least in vertebrates. And so that caused a firing of the pituitary to produce adrenocorticotropic hormone, ACTH, which stimulates the adrenal gland, which generates an adrenaline. And adrenaline actually relieves this constraint because it causes the production of lung surfactant in the alveoli, which makes them stretchier. But it also, in tandem to that, it causes release of fatty acids from fat pads. Fatty acids are very readily converted into energy and into heat. And so that was the origin of thermal regulation and in mammals and birds. It was a side effect, if you will. So next. So oxygenation, metabolism, and endothermy have evolved, as I just described. Next. But this, as I've suggested, exaptation, these pre-adaptive stages are called for from time to time. And here we have a stage in which, in an adaptation to land, there was the evolution of bipedalism. And that, I know it's a stretch, but I think that evolved from this verticalization of these lipids in the water atmosphere condition. And that's actually the predecessor of bipedalism. If you understand that each of these steps has given rise to the freeing of the forelimbs by standing on two legs, that in turn has given rise to tool making. And language, in my opinion, is a subset of tool making. Next. And so we have the full-blown physiology ultimately. Next. And the aggregate of each of these individual steps is what we consider to be our consciousness. And in man, because of bipedalism, there is the evolution of the ability to conceive of past, present, and future simultaneously, which is unique, I think, to humans. There's ample evidence for that. Next. So here's another way to look at this. I'm talking about cell-cell communication as the basis for evolution. I'm going back to the amphiphils, the lipids in water forming micelles, trapping calcium. And then if you permute and recombine that process, Conrad Bloch had shown that cholesterol, the ability to synthesize cholesterol appeared when there was enough oxygen in the atmosphere, but that actually is reasoning after the fact. Cholesterol was an answer to the constraint on cellular evolution, referencing the lipid-water relationship. And so cholesterol was key to vertebrate evolution for sure, and many other forms of life, because it thinned the cell membrane, increased oxygenation, locomotion, and metabolism as a result. Another constraint was oxygen actually acting to cause disruption of calcium stores within cells, which gave rise to de Duve's peroxisome hypothesis for the evolution of the peroxisome. But here again, you see this reference to earlier phases in evolution, which gave rise to the peroxisome, because the way peroxisomes work is to use lipids to mop up the calcium that's been set free within the cell and can be toxic. And so I'm depicting here the water-land transition, which occurred about 500 million years ago. Oxygen and stress stimulated the hypothalamic pituitary adrenal axis, released adrenaline, caused endothermy through the release of fatty acids from adipocytes, fat cells. And in turn, that gave rise to bipedalism, the freeing of the forelimbs, tool making, and language. And I do mention here the advent of lung surfactant, which is a derivative of lipids, which was made it possible for the lung to evolve over time because it makes the alveoli stretchier, if you will. on an ad hoc basis. But the reason I mention the surfactant is because the mechanism by which the surfactant is elaborated is the same mechanism that is used for myelinization in the brain. So you have this coevolution of these two properties, which ultimately gave rise to civilization actually through niche construction. But there is this continuum all the way from these amphiphiles to the elaboration of civilization. And I'm suggesting that language, particularly written language, was essential for civilization. And so that actually is the combination of tool making and language, if you will. And the reason I feel so strongly about this is because the area of Broca and the cerebrum is where both motor control and language are housed, if you will. So for example, when someone has a stroke, that's why people can't, they cannot use their hands for writing, for example, and they cannot speak. Both of those things are affected because of this co-evolution of tool making and language. Next. So epigenetic evolution is homologous, I think, with Peter Rowland's rewrite system, as I will explain. So if I start from the unicell in the case of evolution, and I contrast that with Peter's rewrite system, what I'm suggesting is the unicell and zero, which Peter states is critical for the rewrite system. Both of them are attractors. In the case of biology, the unicell has, as I've just shown you over the many slides I've shown you, has given rise evolutionarily to cellular growth and differentiation as we think of evolution. In the case of the rewrite system, the mathematics is actually consistent with this process, if you will, in the sense that the rewrite system has to recapitulate itself every time you add another row here to the system. The same thing happens in evolution. There's a recapitulation, if you will, through epigenetic mechanisms that tells the organism where it's been and how to deal with an existential threat that's confronting it. So there's this interesting convergence of evolutionary biology and Peter's rewrite system, at least in my analysis. Next. So again, I'm relying here on the Big Bang, the equal and opposite reaction from, to generate homeostasis, to generate all the matter in the cosmos, because without that, there would be no matter. So what I'm suggesting is that life as a boundary establishes the explicate order. Next. So the micelles were the determinant of the explicate order. Before life, starting about 100 million years after the Big Bang, or I'm sorry, after the formation of the Earth, about 4 billion years ago, there was no explicate, there was only an implicate order. Next. And so this process moved us from the implicate next. Next, to the implicate. So now energy becomes matter. So I'm depicting the Big Bang on the left and the recoil, if you will, the equal and opposite reaction, Newton's third law of motion. So in physics, so that constitutes all of the balanced equations that we know of in physics, chemistry, and biology. So in physics, E equals mc squared. In chemistry, sodium plus chlorine equals sodium chloride. In biology, endoderm plus mesoderm equals ectoderm, giving rise to offspring. All of these, in my assessment, are manifestations of the effect of the recoil of the cosmos giving rise to homeostasis being necessary. It's the equal sign in each of these equations. Next. So as for evidence for vertically integrated physiology as the basis for consciousness, which is an outlandish idea, but I'm going to stick to my guns. Again, I go to these ANPA files giving rise to the first principles of physiology. And stepwise, you have evidence for the vertical integration of physiology as consciousness manifest, for example, in near-death experiences. I think that the light at the end of the tunnel that has been described for near-death experiences, it's a calcium burst. It's the last gasp. Peak experiences, as Maslow has described them. Meditation. Meditation is very important because I think it is a recapitulation. It is the reversal of this process in a backward direction. We know that the gut brain gave rise to the brain itself. So we're going back minimally to the gut brain, perhaps even beyond that. Next. So the cell is a fractal. And what I've tried to express here is the idea that if I had a bunch of puzzle pieces and I had the picture on the box of the puzzle and I had the pieces of the puzzle facing up, I could recapitulate ontogeny and phylogeny through cell-cell communication, which is what I've described to you, giving you a finished puzzle for human physiology and anatomy. However, if the puzzle pieces are face down, this isn't going to happen. And so it's essential that you have these cues, the data, in order to accomplish what I think I've accomplished in discovering the true basis for evolution and its relationship to quantum mechanics. Next. So here I'm going to talk about evolution of language and its relationship to civilization and culture from the perspective of cell-cell communication. So again, I start with the unicell interactions between cells through cell-cell communication, giving rise to more and more complicated physiologic structures, organisms, ultimately giving rise to endothermy and bipedalism, the freeing of the forearms for tool making, oral communication being necessary because as a tool maker, if you're trying to express yourself to your fellow tool makers, you've got to explain it. And so that's why there was a selection pressure for oral communication, but it is a derivative of tool making. Subject, verb, object is a tool making process. You are hammering out an idea and you're expressing it. That ultimately led to written communication as the combination of oral communication and tool making, in my opinion, and written communication was essential for civilization and culture. So we see that there is this continuum, next, in which civilization and culture are actually feeding back on this process and promulgating it, next. And in turn, this process has given rise, the process of cellular communication and physiology has given rise to what we recognize as civilization and culture. So this is lovely daisy chain, in my mind anyway. I hope I've explained it well enough so that you might consider this hypothesis. Next slide. So consciousness, our consciousness as the consciousness of the cosmos is a highly controversial idea, which I've published in several communications now, peer-reviewed articles and books. So in the beginning, I'm suggesting again, we have these amphiphiles which are affected by electromagnetic force and photons over eons, and that promulgated the formation of these micelles, and that in turn gave rise to the first principles of physiology, and that the aggregate of this process is what we think of as consciousness. Next. So here I'm going to talk about consciousness, our personal consciousness as that of the cosmos, ultimately. So think of stress affecting us, next. In a downward fashion, the stress is referencing earlier and earlier stages in our physiology, next. Ultimately arriving back at the amphiphiles, they're called zwitterions also. And so we're going all the way back to our origins, physiologically, if we are under extreme stress, such as the ones that I described earlier, the near-death experiences, Maslow's peak moments, etc. Next. But then we reverse the process, but through the first principles of physiology, we go back, we ascend back through integrated physiology, next. And ultimately, next, we are conscious of our being because we use the same natural laws that the cosmos does through endogenization. And so when Chambers asks the hard question about consciousness, why is it that we see red when we whack our thumb? It's because we're relating to an earlier and earlier stage in our evolution when, in all probability, we whacked our thumb and we bled. I think that's the explanation for the hard problem that Chambers has challenged us with. And Clark has also suggested that there is extended consciousness. And I think that the extended consciousness into the environment is explained by this model, if you will. So two critical questions in contemporary psychology and philosophy are answered by this mechanism, for example. Next slide. Oh, I'm sorry. Forgot to mention endosymbiosis. The question of awareness and consciousness came up in Nicola's presentation, if I remember correctly. And I want to distinguish between awareness and consciousness. I think awareness is what I was talking about with regard to niche construction and epigenetic inheritance. And that awareness, ultimately, when it's aggregated, it is our physiologic evolution. And that physiologic evolution equates to our consciousness. So this is the relationship, in my opinion, between
He's not moving.
Johnny's still there?
We can start the discussion.
Yeah. Okay. Well, I'll stop sharing and we'll see if we can pick him up.
Yeah, he's frozen on my end.
Yeah.
See me.
Let's just. Okay. So Lou is going to ask the first question. I'm just going to try and find John. Otherwise.
Earlier in your talk, you mentioned for a moment the anthropic principle. Could you say a bit more about your position about the anthropic principle and what you think about it?
Lou, I'm not sure John can hear you because he seems to have disappeared. Let's just see.
Just a moment.
Just a moment, because so we've got some technical things. Okay.
He's gone.
Yeah, I think. Isn't it weird how you actually get to the end of the presentation and then that happens? At least we got to the end of the presentation. So. I didn't quite catch that, Peter, but I can imagine what you said.
I said a near-death experience.
Yes. Let's. So I'll just email him and just tell him to come in again.
I just called him. He's trying to get back in.
Okay. All right. Thanks, Rich.
Good.
Okay. It's quite a theatrical way to finish a presentation, that's for sure.
It's brilliant, wasn't it? Golly.
Well,
No, I mean, yes.
Yeah. Are you still around, Vanessa? Because you would have. Yeah, where is she? She went into the level of consciousness. Yeah. Because I mean, I know.
I'm here.
Good. Because I mean, you would know. You know more biology than I do. I don't know how many of you are kind of biologically competent, but it so it's really interesting, isn't it, Vanessa?
Yeah, well, yeah, I've worked more with bacteria and viruses and the real elementary.
Right. Yeah.
Sorry,
Well,
I lost you there.
No, well, you can probably answer one of my questions because I was just thinking, like my cells, this semi-permeable membrane, is this just phospholipids? Is this just a cell? Basically a sphere of phospholipids.
My cell is just, a bubble of lipids.
A lipid or phospholipids?
It could be either.
Right, okay. Because I was thinking, obviously, because when we get to cells, then we've got the, you know, the double membrane of phospholipids.
Yes. Well, it depends on which cell you're looking at, because they're all very different.
Technically defined as aggregates of surfactants within a liquid colloid. So a collection of hydrophobic and hydrophilic regions in a kind of head-tail relationship.
Yeah, exactly. Yeah. But
Rich, sorry, can I just interrupt for a second? Rich, are you on the phone to John, or?
No, he said he's on his way back in, and then he cut the call. I'm thinking I should call him back and tell him to zoom in from his phone.
Yeah, I think that's probably best. It's much better to just use the phone if the computer's playing up.
Okay. In answer to Lou's question, John seems to suggest that life could evolve in any universe because it absorbs its enemies.
There's some overtone.
Yeah, sorry, Andrew, do you want to say that again?
John seems to suggest that life could evolve in any different universe, in contrary to the anthropic principle, because life progresses by absorbing things that threaten it by a process of endosymbiosis. If he does think that, that's pretty radical, but you know, that seemed to be, that's what I heard him saying, approximately.
So what does that have to do with the anthropic principle, which suggests that universes, well, you can go take a step back. There might be universes that simply can't evolve a consciousness, or there may be universes that do, and that principle suggests that universes that do somehow have their physical laws tuned in a certain way.
Yes.
I think the objection is it creates a correlation between our present requirements and the laws or the conditions around us, and therefore tries to rule out other alternatives.
Well, the theory is not well enough developed to rule out things.
Yeah.
That's the real objection on the part of physicists, I think, to the anthropic principle, is that it's too vague.
Yeah, I think it goes too far when you say that it has force to prevent other outcomes. And if life is as adaptive, if we have we yet to find an extreme environment where we haven't found an extremophile, maybe space, deep space, but if there is this dialectic process where where life reacts to its antagonists by endosymbiosis, then there'll be less constraint by life on the kind of universe that can support it.
If so, there will be life almost everywhere in the universe and in other universes.
I'm sorry, there would be what? I didn't hear what you said.
In that case, John's theory would suggest that the universe is not only full of life, because we are parochial in imagining that it can only happen on a gentle planet like Earth, and it might be possible in other parallel universes which have different laws of physics. So life might be almost necessary condition of a universe existing.
But it may not be.
Yes, that's quite possible.
I'm not saying that I believe that. I'm saying that's what John seems to imply.
Well, when he gets in, we can ask him.
yeah.
Does anybody else want to share some thoughts about this? I mean, obviously we can run all this by him when he gets here, but
I hope it wasn't too much stress.
Yeah. Well, I think it's very interesting that the stress that technology produces is a very important thing, isn't it?
I hope it didn't trigger any regression.
Mark. You know,
Reg, sorry.
yes. Do you have the digital telephone password?
Digital telephone password.
Yeah. It's not the 20-character hex. It's like 5 or 6 numbers in a row.
Copy invitation link. I wonder if that would do it.
It's in there. You should be able to read it off on the bottom of the screen.
It's 991269.
No, that's the call ID.
Oh, I see. Okay, I don't see any other.
Okay.
There's a, actually, maybe I know that.
Hang on.
Yeah, here it is. If you, John, 0072 72 6375.
Yeah.
Yeah, that's the numeric password after you get in with the call ID. No. Telephone number first. The 991 caller conference ID second, and then the digital password third. Okay.
Can I just remark that I forgot to put my email in when you asked for them, Mark, and I put it in this chat. And
yes.
Anybody else could do the same.
Yes, and I will send them round.
Thank you.
I forgot to send the text from Grenville's talk round yesterday, but I'll do it. I'll do it after this. Okay.
Very sad to have missed Grenville's talk, but I noticed you've uploaded the video, so I'll watch it later.
Yeah. Well, that's the beauty of all of this, is that the videos are there. So.
Did we prove the Riemann hypothesis or not? We didn't get to that bit.
Okay.
Anyway.
I had a little bit of difficulty with the analogy between homeostasis and the proton and electron, which seems like a much simpler relation than a homeostatic relationship. It's just a mutual attraction. And also sodium chloride analogy to reaction.
What I mean, in this context, and also in talking to Peter Rowlands, I'm less certain about what homeostasis is than I used to be. It's a much more multi-level thing, it seems to me, and certainly in Peter's system, a nilpotent seems to be a more powerful way of talking about homeostasis. I don't know, Peter, do you want to say something about that?
Peter.
Yeah, nilpotent, well, you can actually express any system that conserves energy or organizes energy in a systematic way as a nilpotent. You can simply do it. You just restructure your energy equations to do it, and that system seems to have its balance with the rest of the universe, which is its mirror image. So that's how I understand the process to work. But homeostasis in biology is adapting to its environment and changing its environment and changing itself as a result of its environment. And yeah, that's a rather general way of looking at things. It will certainly involve the energy principle, but I don't exactly know precisely how it works.
But if a biological system adapts, it's obviously adapting to its environment, but there's going to be a reaction in the rest of the universe, isn't there?
Yeah,
Just
the
as
reaction
everything
in the
else
universe has to change as well. And the same with any system which has that principle. Any system with that principle has to change, and it will change the universe at the same time.
I think one of the most radical things in your work, Peter, is you confer upon the vacuum the same information content as the explicit, as the fermions and the bosons. So whereas normally we think of the vacuum as sort of big empty, not, maybe a frothing sea, but not actually containing complex structured information. And so I think I was thinking earlier about the lipid surfaces as a kind of interface that creates a correspondence between the inside and outside, in the sense of Huygens principle.
There we go.
So
yeah, well, I think that's is definitely a very interesting way of looking at it. Yeah.
Right, John, I think we have you with us.
We have a problem, Houston.
It's like 60s television.
It's yeah, I'll just make some incidental music.
Early computer lectures, early lectures using computers were like this, weren't they? But when you had to, well, using projectors and so on, it always took about 15, 20 minutes sorting something out before it started.
Yeah.
I can remember that, say 20 years ago or so.
So, John, you're muted. If you can hear me, you're muted, so you need to unmute.
Yeah, I'm fine. Can you unmute him?
No, I can only ask for it. Okay.
Well, look, I'll just say about homeostasis. I thought my understanding of biological homeostasis was not in terms of anything developing anyway. You know, it's like, you know, we have a sort of temperature. We have this mean that is kind of like healthy, and the homeostasis is always like trying to return to something. So it's not actually, I think that is a different idea. I mean, obviously systems do adapt, etc. But in terms of my understasis is actually to do with, you know, having that mean that one returns to.
I think we're just suggesting a kind of generalization of homeostasis. So the very organization of the biological individual is a kind of homeostasis between itself and the universe.
So, yeah.
For just one variable, it's a simple negative feedback where you're compensating for it gets hot, you sweat, so you evaporate, you get colder again. But when you have multiple variables that you're trying to keep in homeostasis, then the relationship between the environmental changes in those will have to be mirrored in some way in the response.
Yeah, the thing is, we have other terms that we use for this more general thing, such as autopoiesis in cybernetics.
Yeah. I mean, that seems to me a more satisfactory term for what is being talked about here. Homeo meaning the same, obviously, and stasis meaning static. So, whereas autopoiesis being self-making, basically. So that's for any adaptive thing, autopoiesis seems to be a much better term.
More dialectical.
I'm happier with that as well. I like to stick to the etymology as closely as possible.
I mean, that raises the question of the relationship between what John's presented here and the theory of Maturana and Varela, and how I sense that there's something different here. This is rather more. There's rather more meat on the bones. Well, literally.
And more questions to ask, because John jumps over a lot of connections that would have to be looked at more closely.
I think what would be considered the most heretical is this reaching back from the civilization back to the cell culture, and what mediates this, you know, retrocausal or this transactional relationship between the end of an evolution and the process.
Hey, you fell off the call.
Sorry?
I saw you on for a second. Why don't I just put my telephone against the computer and have you talk from through
that would work.
Crazy.
Yay!
Keith
Robinson, yay!
Yeah.
We have to be adaptive.
Yes, absolutely. This is
autopoietic.
I have John on the telephone. He's going to talk through my computer.
okay.
Say something, John, so we can make it look like it works right.
Hi, John.
John, Torday, say something.
Perhaps if you use the speakerphone function on your mobile.
There are going to be generations of people following from Richard and John, and you know, with bearing the epigenetic inheritance at this moment.
Fertig.
Okay. One more
Ja, wenn du halt dann zu klein und dann kannst du da mitnehmen.
then
Say something again, John. I'm putting you right next to an external mic.
What the fuck?
I heard that sound.
Okay. Did you hear? Are you hearing John at all?
It's very quiet.
Try again, John.
Chat line.
No, it's not. He's talking. It's not coming through.
Okay,
Right.
look, can I make a suggestion? We finish this Zoom call and just try going in again, because clearly something's a bit nuts.
Okay. Use the same link.
Yeah, you lose the same link. I'll just start the same thing.
Can you save the chat and repaste it, or it may not be possible?
Yeah, I'll save the chat.
All right, John, he's going to close the call, reopen the whole call, and then we'll all start logging in again. Okay.
Ground control to Major John.
Yes. Right, folks, I'm going to finish this call, so I will see you in a second.
Be right back.
Okay. All right. Cheers.
Okay, thanks.